Hello everyone, Josh here from MA Exhibitions. Welcome to today's webinar with Dassault Systèmes, looking at virtual twin experience, resiliency for the next normal. Before I introduce your speaker, I do have a couple of housekeeping points. So there will be time at the end for Q&A. If you do have any questions at all, please use the Q&A tab to the right of the slides, and all questions are private, kept anonymous. You can also use this tab to let me know if you're having any technical issues at all, and I'll do my best to help you out and get you connected. The session is being recorded, and you'll receive an email soon afterwards with a link to watch the recording. Also, if you look in the Handouts tab next to Q&A, you'll be able to download the slides from today, as well as the Delmia brochure. Now, your speaker for today is Prashanth Mysore. Prashanth is a Director for Global Strategic Business Development and Industry Marketing at Dassault Systèmes. Trained in mechanical engineering, Prashanth has over 23 years of experience in technical portfolio management, business transformation, and product lifecycle management solutions, consulting across a wide range of industrial sectors with strong knowledge of the industry renaissance, Industry 4.0, and smart manufacturing technologies. With that, I will hand over to Prashanth for the presentation.
Hello everyone, and thank you for joining this session. My name is Prashanth Mysore. I'm a Strategic Business Development Director for Delmia, the manufacturing and operations brand of Dassault Systèmes. During this session, I'll be sharing with you the next step in digital twin maturity, which is Dassault Systèmes Virtual Twin Experience, and how it can deliver the operational resiliency to help you compete in the new or next normal that is now beginning as we come out of this very disrupted period. During this session, I'll provide a definitional background on Dassault Systèmes Virtual Twin Experience, talk about what is required to create one, what the next normal requirements are that will require this capability, and then showcase some examples. But first, let me provide some background on Dassault Systèmes for those of you who may be unfamiliar with our long history in 3D technology. Dassault Systèmes is the 3D experience company, as most of you know. We are a purpose-driven company. We think of progress and innovation in terms of balance and impact. Harmonizing product, nature, and life lies at the heart of everything we do, and we bring to the world. We have about 20,000 passionate people from 130 nationalities across the globe who are at the heart of the company. We also have large R&D teams connected across 64 labs. Dassault Systèmes has the largest PLM and 3D experience market with more than 270,000 customers in 11 industries worldwide. And our 12,600 selected partners increase our collective knowledge and reach in the areas of technology, sales, services, education, and research. The composition of our shareholding pattern has been consistent since our introduction to the stock market. The majority of the company is owned by the group and the company's management. This stability enables a consistent long-term strategy and long-term investment, enabling us to be one step ahead of the competition. Okay. As most of you know, we have been the catalyst and enabler of the world's greatest industrial transformation. Every decade, we have helped manufacturers to disrupt how products are designed and made, and to rethink their whole development and production methods. And now we are entering the fifth stage of our journey. The first stage was 3D design to represent the surface of things. This was marked by the launch of CATIA to create and engineer parts and assemblies in 3D. The transformation has been the high performance innovation achieved right the first time, and our customer has been Dassault Aviation. The second stage was 3D digital mockup, 3D DMU, to represent entire complex systems inside and outside. 3D parts came together to simulate the complete engineering context of a virtual model, replacing physical mockups. This is where we created the first ever digital twin of Boeing 777. Okay. The third stage was 3D product lifecycle management, 3D PLM, to represent time. This is what we call the lifecycle or the end-to-end product management entirely in 3D, from design through to recycling, including production and distribution. Transformation has been at every stage in the value chain, and our emblematic customer has been Toyota during this time. The fourth stage was 3D experience to represent perception and emotion. This has been an important milestone for Dassault Systèmes. Today, value lies in the usage rather than the product itself, right? That's what we call the experience economy. We help our customers to create delightful experiences of their customers. The transformation has been the innovation by and for the consumer citizen. And our customer during this time was a very innovative project, which is the City of Singapore, based on the 3D Experience City technology. Now we have entered the fifth stage of our journey, moving from the representation of things to life. Imagine being able to model, test, and cure a human body as well as we do with a plane or a car, right? We call it a virtual twin experience of humans. A virtual twin experience of the human body with the 3D experience platform integrates modeling, simulation, information intelligence, and collaboration. It brings together biosciences, material sciences, and information sciences data from an object into a complete living virtual model that can be fully configured and simulated. This is towards sustainability, and it will help multiple innovative projects happening during this situation of pandemic, right? And this is where Medidata has joined Dassault Systems. Our customers are recognized leaders across 11 different industry verticals and are recognized for both their product innovation as well as their operational proficiency. And our relationship with these leaders is of interest beyond just proof of competency because of the best practice sharing that goes on between industries. Example being high-tech industries interested about adopting car assembly processes to their devices, and construction companies are adopting manufacturing processes in order to deliver modular components from factories to the construction site. There is a cross-pollination of best practices happening across these industry verticals. Dassault Systems' support for these leaders is built around the concept of a sustainable global operations framework built on 3D experience platform, where we are focused on human experience or people, your enterprise value network, which drives profit, and the virtual twin experience, which drives efficiency and reduced waste, which we call planet. And this is where we will focus our discussion today. Together, they are the three P's of our sustainable global operations framework. So now let's define the virtual twin experience and put it into context. Okay. The 3D experience platform is both an innovative platform supporting collaboration across the value chain, as well as the business experience platform that is both a system of operations to run the business and business model to transform the business. It is the foundation for supporting our virtual twin experience. Okay. It all starts with the creation of a 3D model so that you can virtually see what you want to accomplish, whether it's a product, a machine, or a whole factory of machines, materials, and people to produce thousands of millions of products. Equally important, though, is the real world execution, because actually making a product or providing a service is how money is actually made. And in that process, the learning and experiences taken from the real world processes are then used to update the virtual twin model so that you can not only improve the business and unleash new business models from a manufacturing knowledge. Achieving this closed loop capability is what we call platforming your business, the full realization of benefits to be gained from the convergence of virtual and real worlds, what we call it as V plus R. Okay, this is imaginative, it's immersive, it's collaborative, and it's productive, and it's driven by model-based engineering approach that is embedded in 3D experience platform, so that every stakeholder across the enterprise is collaborating with the latest information which is available. And we support this model-based approach with technologies like augmented reality, virtual reality, 3D printing, and industrial Internet of Things communication. In its purest state, we bring together the people of your enterprise to collaboratively innovate, drive profitability for your company, and help sustain our planet through virtual twin experiences by determining what's possible based on the application of knowledge and know-how. So we define the virtual twin experience as an executable model of a physical system which brings in learnings and experiences from the physical or real world to update the virtual twin experience, right? And digital twins are static, whereas the virtual twin experiences are dynamic, providing an ability to visualize, model, and simulate sophisticated experiences, not only of the product, but its manufacturing environment as well. This closed loop ability provides the full realization of understanding what's possible, thereby driving innovations both small and large across your organization, while empowering your workforce and creating new resiliency in your value network for the next normal. Okay. So now let's briefly look at the value proposition of the virtual twin experience. As a result of recent pandemic, we see leading organizations assessing their ability to pivot quickly in response to disruptions or new opportunity, reassessing their manufacturing strategies and supply chain performance and how resiliency can be increased. Okay, and some organizations are really looking at relocating operations nearer to the end customer to protect against supply chain disruption, and sometimes obviously they have to comply with regulatory mandates, right? This is where the virtual twin experience can have a significant impact in these kind of scenarios by utilizing a virtual model so that what's possible is always understood before the action is taken in the real world. That includes ensuring the safety of workers, visualizing and simulation of cells and lines that can help not only to identify safety issues, but to clearly separate value-added activities from non-value-added activities. And the ability to fully simulate the end-to-end factory flow that includes like 5Ms, man, machine, methods, material, and measurements can drive a new flexibility and productivity into your physical operations on a continuous basis, delivering the actual value of increased resiliency. And the virtual twin experience capability is applicable across different entities within the value network, right from OEMs to machine builders to system integrators. And this is across all industries because experience is related to your product and its production and its usage, and even the impact on environment is applicable all across industries. So now let's take a look at how you can bring a virtual twin experience to life within your company or organization. Okay. First, you start by creating a digital model of your shop floor. There are two possibilities in making this happen. Okay, the first, you can start by performing a 3D scan of your facility or your production line, creating a digitized cloud of points of your factory layout. We work with our ecosystem partners to help you scan your existing facility or asset, and this can be done via mobile technologies with greatly shorten the time it takes. And the second is to use a more traditional approach of using 2D layouts to build a 3D model of your factory or the line, which also gives you an added advantage of establishing greater infrastructure granularity, including utilities. This could help in future projects if building expansions are needed, right? And the second step, you will leverage the 3D experience platform to expand your 3D factory model using the many resource catalogs, the 3D experience catalogs, which we have developed through the years to build up a 3D model. And at this point, you will position all your assets, taking into account worker safety requirements and standard operating procedures. And in the third step, you will define and simulate all of your tools, robots and machines, as well as worker interacting or interactions, synchronizing every aspect of your organization from starting to the final checkpoint. You'll now be able to execute continuous improvement activities across your operation, as well as validate product variants and everything within the 3D experience platform virtual twin experience. Okay. Smaller lot sizes, shorter times to market, and lower manufacturing costs are some of the trends which we've been seeing currently, and these will drive the adoption of agile and lean manufacturing approaches. As we all know, there are about 15 plus lean manufacturing principles which could be adopted while you're creating a virtual twin experience. But the question is, why lean manufacturing now? And as you know, the Toyota Way and Toyota production system began during and as a response to tough times in Japan after World War II. Although lean is often thought of as a system to solve already known problems, it's really a system to help us create new and better ways to work and the new and better products, and as a way to revitalize the human spirit, communities, and organizations. And in tough times like this, like we are in now, we can all help by creating these new ways by adopting lean manufacturing principles. And some things to think about it, right? How could an organization make something that is scarce but needed? For example, if you're in a related industry, how could you make masks or gowns or personal productive equipment kits, even if you don't know how to make it? So this is where I say, to cater for an unpredictable demand environment, a manufacturing restructuring framework can adopt the lean principles to fast track plans for agile manufacturing processes. And how can your organization use these kind of skills and product to help others? And how can your organization adjust how it delivers product and services like ventilators, etc.? Let's see how to make this happen. So now let's take a look at how these three steps would actually create a virtual twin experience. You can see in this video that we are building up the 3D factory structure using the 3D Experience platform, as it has all the tools and templates necessary to help you create the factory model from any available 2D documentation like BIM models, factory footprints, CAD files of utilities, and even physical rendering, which can be accommodated by the 3D Experience platform with the goal of creating a sustainable twin of your physical operations that help you avoid costly redesigns by enabling users to collaborate and share views of your layout and create a closer collaboration with your suppliers. Here, what you're seeing here is that we are reusing existing rich catalog of resources to populate the production line or a work center. You can also position and manipulate various resource positions in 3D by reusing a rich catalog in 3D Experience platform Plant Layout Workbench. You can validate and define factory floor with attributing resources. The idea of actually doing the benefit being avoid costly layout redesigns by enabling users to collaborate and share 3D models of the 3D layouts. And if you're working with a supplier, there could be an efficient supplier collaboration thanks to 3D Experience platform collaborative processes. And you can define various types of layouts here. In this case, you are seeing a U-shaped layout as part of your lean manufacturing principles. The second step is to use the initial 3D factory layout and to add in all the machines, tools, robots, and other resources to support the production scenario. In this case, let me run a video. In this case, we are also showing how a 3D scan of the facility can be used to create the factory layout that would then be modified to reflect the final factory flow. This can be an independent step or can be an extension of your first step. Okay, we can help with our partner ecosystem to scan your facility wherever the scanning is possible and the lockdown restrictions are not there, and we can bring in cloud of points into plant layout application and create a virtual twin. Right, and during this step, a layout problem can be easily spotted and immediately adjusted. The resources like robots and tools and conveyor equipments can be validated in the context of the virtual environment that they will be operating, right? And as we are working on collaborative platform, we can find equivalent resource models from the library tools or the catalogs which you saw in the previous step, and they can easily be instantiated into this 3D world with a better level of details on the model. Okay, an additional benefit from actual customer situation is that the validation of the sequence in which equipment is installed in the factory, ensuring that the physical movement of machines into position on the shop floor that can be done based on available clearances, the safety clearances and the safety space, by bringing in quality, health, and safety environment into your factory layout. Okay. In the final step in creating a virtual twin experience of your factory, such as automotive seat assembly line, and this is to fully simulate your factory operations using your defined routings and processes in order to virtually see and understand the synchronization of all the moving parts. Example being your material, workers, production line, robots, and machines, which includes the activities being able to bring in planning data and execute actual production runs to determine where adjustments are needed to be made, or conditions optimized both on a machine and on a worker basis, where you can actually validate multiple KPIs. Sometimes it doesn't work, but that's okay in the virtual twin experience, because that's exactly when you want to find out whether the worker safety is compromised by a badly programmed robot, or an AGV is delivering pallets to the wrong spot on the line, or whether the forklift can turn around in a space next to the line itself. No one will get hurt, no equipment is damaged, and once the changes to the processes are made, the same scenario can be validated immediately. Once you have created this virtual twin experience on the 3D Experience platform, you're now able to fully realize the benefits of virtual plus real, and drive a new resiliency in your operations through agility and flexibility. The objective is to design factory layout and analyze multiple production scenarios here, whatever you're seeing on the screen, and optimize process performance with alternate product routings so that you can bring in agile manufacturing and optimize production performances. So now let's look at how the recent global disruptions caused by this pandemic are creating what some are calling the new normal or next normal. Okay. As you see here, we have listed 5 trends that are clearly at the forefront of changes as indicated by industry analysts and customers as a result of the current events. And the driver for all these actions is to create more resilient operations that not only withstand significant disruption, but can help drive a leaner, more agile organization that thrives on innovation and is prepared to grab competitive advantage. Okay, and let's briefly talk about what are these emerging requirements. Okay, and as we have seen recently, remote monitoring and control of operations is critical in minimizing operational disruption that can be caused by any number of factors. It can be natural or man-made. Plant level tasks that can be remotely done by a center of excellence or a remote operation center, or even at home office, will be much more widely adopted, right? And the worker safety is paramount, considering the new regulatory guidelines and the worker safety protocols that are being practiced around the world. And this is having a significant impact on production requirements and the production environment, extending from shift start times to supplying workers with personal production equipment, PPEs. As an example, General Motors has estimated it will require 2 million masks per month to supply just to its US facilities, right? And as a result, GM is now producing face masks at 5 plants around the world. And now the digital acceleration is going to kick off, and it's kick off into a high gear as we see manufacturers look for solutions to increase the automation of the shop floor and a convergence of IT and OT technologies within the context of IoT adoption. And even onshoring of operations is a trend that is already taking off as manufacturers seek to reduce their disruption risk and move manufacturing closer to the local economy and to the local or the end customer. And finally, we've been already seeing this growing interest in adoption of virtual twin technology within organizations, and we expect to see this accelerate from selective applications within the strategic projects to a larger manufacturing transformation approach. Let's see some of the examples of how these trends are shaping up the technology and virtual twin experience. Okay. As I said, let's take a quick look at some examples of virtual twin experience can impact the requirements of next normal. As I just said, we are all seeing this. New worker safety protocols are having a major impact on plant level operations, right? One of the large impacts is driven by the impact of social distancing recommendations meant to reduce the spread of these disease and the airborne viruses. This scenario I'm sharing with you now is a section of a large production line where social distancing has been a major factor. By employing the virtual twin experience, we can specifically see what this impact and when we reduce the number of workers to meet the physical distancing requirements. A reduction of workers from 9 to 3, and similarly a reduction in the production output can be quickly validated. With the virtual twin experience on 3D Experience platform, the scenario can be validated, analyzed to the level of seconds, and from this, any number of what-if scenarios can be run to figure out the optimal approach for social distancing on this part of the line. Okay, and once this is optimized, once the various scenarios are optimized, the 3D Experience digital process plans can be updated and sent to Delmia Manufacturing Management Solutions for review, testing, and acceptance as the new execution process for this part of the line. And this kind of end-to-end application of virtual twin technology as provided by 3D Experience platform to address various challenges, unknown and known challenges, is what industry leaders and innovators are seeking. Okay. Now let's look at another case that will be familiar to many of you based on recent pandemic responses. But let's also look at it in terms of how it could help your business as a part of next normal. And that's the ability to quickly pivot and begin making products you have never made and in plants that were designed to making something else. Right? Of course, the familiar case I'm referring to is the quick pivot made by several automakers to begin manufacturing respiratory ventilators in their plants, and many of them also converted operations to make personal protection equipments, as I referenced earlier. So the current examples run the spectrum from relatively simple products to complex med devices. As you can see here, we have complete use case that addresses the pivot to building a portable ventilator using 3D Experience platform, from product design through to manufacturing execution. However, I want to focus on manufacturing and how a virtual twin experience can facilitate the changeover from a seating assembly line to a ventilator production line. Okay. Let's start by reviewing the entire line in context, taking into account the processes, the people, the material, and the machines in this case. You can digitally perform required layout modification using our catalogs of standard assets and tools, which you have seen in our previous steps. Of course, we now have added the requirement of social distancing on the line, which is easily accounted for in your reconfigured virtual twin for ventilator production. Okay, a significant benefit is the ability to test different production scenarios, taking into account product variability, such as in-hospital ventilators with portable ventilators, especially building in flexibility and agility here. And maintaining worker safety and productivity is paramount in the next normal of manufacturing, so that ability to simulate operators' behavior has even more importance now. And being able to validate the span and reach of different mannequin sizes will help ensure a safer and more production environment. In this case, you're seeing the safe distance norms are achieved through an envelope, the safe distance envelope created for the manufacturing lines here. The virtual twin experience helps to connect the 3D world with the real world through generation of detailed 3D work instructions that can be presented into the operator both on fixed and mobile devices through Delmia Manufacturing Operations Management. In a collaborative environment, parts can be produced using additive manufacturing, whatever you're seeing here, and machining, and the transfer of finished products into the assembly process, which can also happen. So the benefit of virtual twin experience is driven from a complete end-to-end ability to visualize, model, and simulate your operations as you pivot to new products with a higher degree of confidence as to tackle the challenges of next normal. So this is where we are working with few startup companies and help them quickly produce new medical equipments, and this process can be replicated by OEMs, industrial manufacturing companies, and even SMEs. Another interesting example as a provider of advanced production and technologies, Canadian-based Centraline Windsor Limited innovates better ways for manufacturers to avoid costs, maximize productivity, and accelerate time to market. Okay, Centraline specializes in advanced automation processes and joining technologies for resistance welding, metal forming, and cold spray applications. It's vertically integrated product offerings, ranging from welding consumables to fully automated production systems. Let's listen to their story about how Centraline has actually used virtual twin experience for their operations.
Design and simulation to get the perfect product for our customers on the floor.
Delmia on the platform has really helped us out, reducing costs, being able to meet those short timelines. Before Delmia, it was commonplace for a robot to actually be lagged down and then have to move once they powered it up, realized we didn't have the reach. Now, with all of our projects going through Delmia, we don't have that problem anymore.
We've actually experienced about a 15% tangible productivity gain, and that came mostly from some of the intuitive graphical interface, and also some of the tooling and the revamped items such as spot welding and arc welding. One of the examples for arc welding, it completely changed our process on how we simulate an arc welding cell. We can generate the arc trajectories, and it's completely graphical interface. We can give reports out to our customers to indicate this is the angle that you're going to be welding at, and this is what you'll be receiving at the end of the day.
Our customer comes to us with a arc welding project, and usually comes with certain parameters of the angles of welding. The arc trajectory function allows us to show the customer that we are staying within the parameters. And even if we have to deviate from the parameters, we're able to give the customer an exact degree, an exact measurement of how far we deviate and if this is still okay for their process.
Delmia Robotics on the platform allows us to give our customers the peace of mind that they require. By utilizing and building their system virtually, we're able to demonstrate that we can produce this system on time, on budget, and at the required cycle time that they need.
As you heard from Centerline experts that they've reduced tooling related issues and rework up to 90% and programming time on the shop floor by up to 70%, delivering on time and on budget. Okay. With the shifting customer preferences and rapid developments in technology, today's automotive manufacturers are facing challenges that industry has never seen before. At a recent Dassault Systems event, one of our speakers included Honda's Ron Emerson, Associate Chief Engineer of Honda North America's virtual maturation team, and who explained how company continues to overcome these challenges using Dassault Systems 3D Experience platform and Virtual Twin Experience. As a part of this team, Ron uses Dassault Systems Virtual Twin Experience to simulate Honda's production processes from concept to customer delivery. Let's listen to Ron. And before I play this video, you should know that the term Gemba. Gemba is a Japanese term that translates into the real place. When used in the context of workplace improvement or increased efficiency, the Gemba is the place where actual work is done. Let's hear from Ron.
Our vision is to realize the full potential of the virtual methods to simulate the Gemba. Now, the Gemba is a word we use inside of Honda that means reality or at the spot. We want the simulation, the virtual world, to look exactly like our manufacturing situation for what we're doing. Now, we have a strategy from the model to the layout program all the way up to simulation. This is what we want to accomplish. Again, to keep it in the context of the plant. What you see in the bottom center area is the virtual build context. That's what I showed you before. That's where we are. The images going up and to the right are what we've created and are continuing to enhance. So we had to start with building the plant. As I mentioned, we only had 2D data. We don't have any 3D data history where we can rely on. So we had to build the basic foundation of the plant, to model that with a great precision. Beyond that, now we have to do conveyor simulation. This is really critical for us to understand how the product moves through the plant in its various build-up states. So we work very closely with Dassault in order to understand how to model it, how to program it so that we can get the logic to work correctly as well. This is the actual instrument panel line. And now connect that to the modeling. This is where we're really focusing to improve the accuracy and make sure that it matches reality. So we've got the kinematics of the modeling in there for the fixturing that the associates have to move up and down to do the assembly work. We've got the conveyance systems. You can look at the local areas. And then finally at the entire work area in context. And you can see all the logistics containers around that where we can expand that further into the future. Now going to the main line, we're able to simulate what is it going to look like. And this is great. As much as Honda likes to move models from plant to plant, it's really an easy way for us to verify, can we put this model in that plant? It's reflecting the actual manufacturing plant condition. This was critical in what we wanted to accomplish. And of course, we're laying the groundwork as we continue to enhance and develop this area for future activities. You can imagine the logistics and the carts running around inside the plant to simulate that and find the optimum delivery routes, for example. So in summary, we've accomplished a lot. But specifically, realize the full potential of the virtual methods to simulate the Gemba. We've got to understand that actual situation. And Dassault Systems, Honda's achieving our simulate the Gemba vision using the 3DX tools. Thank you for your time and attention.
So this is how Honda has actually used virtual twin experience technology for their productivity improvement. Okay. Now let's see how virtual twin experience can be applied in an interesting project in China. Our partner in China, Aiden, a specialist in facilities management and modular construction of factories, warehouses, and hospitals, was able to design, engineer, manufacture, and construct hospital in 21 days Yes, I said 21 days. The key to their success as a best practice expertise in construction, but also their use of 3D experience platform to design, engineer, manufacture, and connect the modules at the building site. Let's quickly see a reference here. As you can see, Aiden used Dassault Systems CATIA Smart BIM, which is Building Information Modeling, to do conceptual design, space planning, asset design, and even medical equipment integration. They were able to quickly define modules and optimize them for maximum space utilization, bring in the standard norms and safety considerations as a part of their design. Within the smart modeling capability, they can bring in modular manufacturing concepts that help to create lean and flexible assembly operations as well as efficient installation processes, which I can focus on now. As you know, the construction companies are bringing in best practices from manufacturing processes. In this case, manufacturing bill of materials is defined, which is nothing but to define a construction sequence where we can use BIM management and process modeling capabilities to establish sequence of construction as manufacturing bill of materials, so that they can sequence they can see the order of module to be shipped and built at the site. Once the sequence is established, we can run equipment analysis to determine crane size and simulate the module installation so that the critical resources are required for the build as and when they are actually needed. This we call it as 5D and multi-D planning and simulation, where various cranes and resources can be simulated as in the real world. Once the sequence is established, we can run equipment analysis to determine the size of the crane and simulate the module installation and which are the critical resources are required, right? And as in manufacturing, 3D work instructions can be generated for on-site workers to ensure proper assembly, utility hookups, and equipment integration presented to the workforce via tablets and smartphones through our manufacturing operations management technologies. This is an impressive feat, right? And they executed at a time of crisis, and as a perfect example of how virtual twin experience can help to drive new innovative thinking to the existing businesses. And they've also used IoT and augmented reality for their extended business. Okay. So let me leave you with some final closing thoughts here. It's not only an end-to-end solution, but we can also cater to modular business processes like NC manufacturing, robotics programming and validation, additive manufacturing, and human simulation, etc. with the values like lowering cost, faster development, optimized time to market, increased safety, and reduced footprint. So my call to action is as follows. We have gone through a very tough time in manufacturing over the last few months, and we are slowly starting to come out of it now. All right, and what awaits us next can't be known for sure, but I think there is starting to be a universal argument that the old normal is history and we are entering the new normal or the next normal. And as we begin to recover from the loss of recent business, manufacturers need to recommit to an accelerated plan for digitalization of their organizations. And I would argue, and I've tried to make the case that the virtual twin experience based on 3D experience platform should be at the center of your digitalization strategy for manufacturing and operations. As you have seen, the values delivered are compelling, but the greater value is to help you achieve a higher degree of resiliency in your operational efforts, to act with agility and flexibility across your manufacturing and supply chain operations so that you can take the advantage of opportunity and adjust to unforeseen events. So with this, I've come to the end of my presentation. I want to thank you all for joining us today. I hope you have enjoyed this presentation. If you need help with any of the manufacturing challenges we presented, please reach out to us with the email address given during Q&A session. With this, Josh, over to you if you have any questions which we can take it up. Thank you. Over to you, please.
Thank you, Prashant. That was an excellent presentation. So as you mentioned, we now have some time left over for questions from the audience. if you'd like to ask a question, you can use the Q&A tab just to the right of the slides on your screen. But I can see, Prashant, that we have some already, so let's dive straight in, shall we?
Okay.
First one here. Do I really need to build first the full 3D view of my production line or my plant before I can expect to get benefits out of my digital twin?
The answer is yes. We are talking about the benefit of 3D and 3D experience here, right? But the proposal is on the level of detail. As some of you know, the level of detail 1, 2, 3, 4. The 4 being the highest or the more detailed level of details here. We don't need such details to start with. We can start with basic representation of your plant in 3D using our existing catalog of resources, which is easy to build using 3D Experience platform. And that's a good starting point to develop your virtual twin experience. So we can use those the basic 3D layout for modeling and simulation of various manufacturing processes, be it robotics, be it human safety simulation, even the movement of material within the factory itself. This is how we start. Back to you, Josh.
Thank you. Another one here then. Is it possible to export the 3D layout to augmented reality devices such as Microsoft HoloLens?
That's an interesting question. Augmented reality, yes, the 3D layout, and I would say here the static 3D layout, which through walkthroughs and you can actually identify all the safety issues and all, can definitely be exported into augmented reality devices. Okay, but if you want to see the simulation model, it is only done through virtual reality. The VR devices, you can have a robotic simulation, human simulation, like robots working in the factory, or even cobots, which are collaborative robots, even workers. So you can actually see through those simulation can be seen through virtual reality. But to answer to your question, yes, augmented reality, the static 3D layout can be exported.
Thank you. Another attendee here says, thank you for the clear definition of the virtual twin experience. Based on your definition, there has to be an integration with the real world, maybe using technologies like IoT, automation, etc. Where does that fit in here?
Yeah, that's an interesting one. As some of you know, we have established a clear path for an enterprise virtual twin experience to support the complete transformation, right? There are 4 stages of virtual twin experience. So the 4 stages are collaborate. You need to collaborate within your enterprise and across your supply chain, even with your customers. That's the first part of collaboration. The second part is modeling and simulation. This is exactly what you have seen today. You have seen today modeling and simulation and collaboration. The third part is optimization of your schedules, optimization of your layout, and a part of it you have actually seen in my presentation. And the fourth one is execution part. This is where the real world will start to collaborate with the virtual world. Means we'll connect to your machines, connect to your machines through IoT infrastructure, through sensors, through PLCs and SCADA, etc. And this is the next part of the overall modeling and simulation part of it. Okay, and some of you are interested, please write to us. We'll give you the complete roadmap, not just the modeling and simulation collaboration, even optimization and execution using IoT and automation. And now the virtual twin relies on the multiple business processes. It's a maturing technology. We need smart automation and IoT for connected control. Obviously, we need to start with product lifecycle management, which is coupled with 3D CAD, which is computer-aided design, and we'll have digital simulation, and we'll also have manufacturing operations management to support overall manufacturing processes. And one of you have asked this question, we can also integrate with augmented reality and virtual reality. So all of this constitute a part of virtual twin experience within Dassault Systems platform.
Great. And can you please explain some of the security aspects of the on-cloud solution of the 3D Experience platform?
Yeah, as you know, we support both on cloud and on-premise. That's a key differentiator of 3D Experience platform, 3D Experience platform on the cloud. The some of you have heard of this concept of security in depth at Dassault System, which relies on the fact that several independent mechanisms are put in place in order to mitigate any single risk. Okay, it also follows industry standards and best practices wherever it's applicable. And when it comes to application security, the platform includes comprehensive access controls, authentication mechanism, including the availability of two-factor authentication. And some of you already know this. All the communications are done through secure socket layer and transport layer security channels with 128-bit encryption. This is the highest level of security on cloud, which you can expect.
Great, thank you. We have a couple more left here, so please do get your questions in if you want to ask one. So the next one is, how does this work in an engineer to order heavy industrial environment that spans multiple buildings?
Oh, cool. So engineer to order, which is mostly in engineer to order or build to order kind of a scenario. Wherein you can start to really create the twin using our existing tools and technologies. You can also bring in engineering, procurement, and construction kind of companies to collaborate with you. When you start to demonstrate your virtual twin to your customers and using your immersive reality and other applications, this you can actually get a buy-in from your customer, right? That's the first aspect of it. And later on, when the fabrication and assembly started, your customer can conduct 3D planning reviews, and you can collaborate with your customer using a virtual twin experience on 3D Experience platform and ensure that their requirements are correctly covered. And you can also share during the early stage itself, which reduces the risk of misunderstanding, design compliance, design for manufacturability, design for safety, etc. And you can save a lot of cost and time by reducing rework if you do upfront planning using virtual twin experience. Okay.
Thank you. This looks like the last question we have then for today. Do you see a value in proposing the virtual twin experience to power plant and energy projects and EPC companies?
So as I said, it's kind of related to engineer to order kind of a scenario there, right? Definitely, yes. Engineering procurement companies can actually work with their customers and start to collaborate at the early stage of their design itself. This industry, EPC and then power plant industry, the profit margins are so less. Any savings or upfront optimization is extremely critical, and you can actually avoid a lot of delays in handing over of projects and plants, so that you can save on those delay costing, right? And once the construction is started, you can conduct a lot of reviews, as I said earlier, with your owner operators, and ensure the requirements are correctly covered, including health and safety aspect. That's extremely important now, and you can cover health and safety aspects and other remote operations and remote asset management, etc., using virtual twin experience. Okay.
Perfect. Thank you. Okay. Well, I think that brings us to the end of the session. Just a reminder that everybody can download the slides from today plus the Delmia brochure in the handout section just to the right of the Q&A tab on the right of your slides. This session has been recorded, and you'll receive an email soon with a link to the recording, as will maybe any colleagues who can attend today. They'll get the email as well if they were registered in advance. You can see there on the bottom of the slide contact details for Prashanth and his team if you have any further questions or if anything springs to mind after the session. But with that, I'll leave it there. Thank you, Prashanth, for the engaging presentation and for answering the audience's questions. And thank you, everybody, for tuning in. And we will see you next time. Goodbye.